determine whether the following equation is exact. If it is exact, find the solution. So this is given in the form of function minus another function y prime. Y prime here represents dy over dx because the x is there as well. So dy over dx. So let me write this in the standard form like this. Some function m dx plus n dy equals 0. And we check, we find my, the partial derivative of m with respect to y, and partial derivative of n with respect to x. If they are equal, then we say this equation exact. Okay, so let me write this in a standard form. So dy over dx, let me put dx here. So this is 1 plus natural log of x plus y over x dx, and I want to put plus, so I want to distribute this negative 1, negative negative positive, natural log of x minus 1. This is dy over dx here equals 0. Okay, now this is in the standard form like this. This is m xy, this is n. Now we find partial derivative of m with respect to y and partial derivative of n with respect to x. If they are equal, then this is exact. Okay, let's find the derivative of m with respect to y. In this case, x is constant, so 1 is constant, derivative is 0. Natural log of x, a function of x, also constant, 0 plus, so 0 plus 0 plus x is constant, so 1 over x is constant, derivative of y is 1, so this is 1 over x. Okay, how about ny? Let's find nx, sorry. Let's find the derivative with respect to x. Derivative of natural log of x is 1 over x minus derivative of 1 is 0, and my and nx, they are same. Okay, so the equation is exact. The given differential equation is exact. That means there exists a function f such that the partial derivative of f x with respect to x is m, and partial derivative of this f with respect to y is n, and the solution will be this f equals a constant. Okay, then there exists f such that partial derivative of f with respect to x is m, which is here 1 plus natural log of x plus y over x, and let's say equation 1 for future reference, and f with respect to y is n, which is natural log of x minus 1, and f, we are trying to determine the function, unknown function f. Okay, this is derivative of f with respect to x. Now we want to integrate one of them. If you want to integrate one, we need to integrate with respect to x. Okay, if you want to integrate this, we need to integrate with respect to y. So try to choose the easier one. So this function, the second one, looks easier than one, so we can integrate 2 with respect to, this is derivative with respect to y, so y we get. Okay, we could have integrated with respect to x, it depends. Okay, but this one looks more complicated, so let's choose this. So f y, we are trying to integrate with respect to y, natural log of x minus 1 with respect to y. This is just f now, and we are trying to determine f. Antiderivative of natural log of x with respect to y. With respect to y, this is constant, so times 1, and antiderivative of 1 with respect to y is y times y. Natural log of x times y minus antiderivative of 1 is y plus constant of integration, and this could be a function of x as well, not only c, it could be some function of x, because x is also constant in this setting. So let's write hx. This could be a pure constant or some function of x. Okay, now we have not used 1, So to make use of 1, look at fx. So find the partial derivative of 3 with respect to x. Okay, and then fx, derivative with respect to x. So y is constant, and derivative of natural log of x is 1 over x times y. So this is y over x minus derivative of y, that's 0, because we are finding derivative with respect to x, so we don't have to mention, plus derivative of h with respect to x is a pure function of x, so it's just a regular derivative, 4. Now we compare 1 and 4, because our function f is given here. All we need to know is now h. For that we compare 1 and 4. Okay, when we compare, the left hand sides are same, y over x is same, so h prime x, okay, h prime x should be equal to 1 plus natural log of x. From there we should be able to find h. Okay, then comparing 1 and 4, we get h prime of x is 1 plus natural log of x. Okay, now we need to recover h, so integrate both sides with respect to x. So h prime x with respect to x is 1 plus natural log of x dx, and this is just hx. Antiderivative of 1 is x plus, now the question is, what is the antiderivative of natural log of x? What is this? Okay, antiderivative of natural log of x. Now we need to go back and use integration by parts, okay, using calculus 2. So u is natural log of x, dv is just dx, so du is 1 over x dx, and v is just x. So we are using integration by parts. U dv equals uv minus integral v du. So uv, so natural log of x times x, so let me write in this way, x natural log of x minus v du, x times 1 over x dx, just 1 dx. Okay, so this is x natural log of x minus, this is 1, antiderivative of 1 is just x plus c. Okay, so antiderivative of natural log of x is in fact x natural log of x minus x, and plus constant. This constant will be absorbed later when we write down the solution f, uppercase f equals c, so we don't need c, or if you can write c if you like. Okay, that means hx equals x minus x, we can cancel, so x natural log of x. So our function f is here, and we just figure out h here. Okay, thus the solution is f equals a constant, so f means this equals constant. Thus the solution is f equals c, which is, let me write, y natural log of x, y natural log of x minus y plus hx, hx is x natural log of x equals c. If we had plus c1, then we could have moved to the right side and just see. So this is final.